Hello everyone. Welcome to this tutorial session 12 on the topic Mechanics of Solid, having the course code NOC-24 CE76. Firstly, today in this session, the main agenda is to first discuss the week 12 lectures. That means in this part, basically, if you are having any doubts related to week 12 lectures, then I will take those doubts first. If there won't be any doubt, then we will directly move to the problems related to columns, or in general, a miscellaneous questions will be given from all the topics. It will be a mixed problem solving session containing questions from each and every chapter, so that you will get a knack of and how to solve those questions. In addition to that, you will get a wholesome practice of all the questions related to each and every part of this lecture series. Okay. So again, I am welcoming everyone to this tutorial session 12. So before moving on, please let me know if I am audible and visible to everyone or not. Please type it in the chat box. Okay. Okay. So if I am audible and visible, please now post your queries and doubts if anything is there related to the contents of week 12 lecture. Or please unmute yourself or talk to me directly if you have any queries related to week 12 lectures first. If there won't be any doubt, then we will directly proceed to the questions for today's session. Basically, first I will solve all those leftover questions from previous session. There are basically one question and three bits are there. Basically, three questions are there, or two questions you can take. Those questions we will first solve related to shear stresses. After that, we will take up questions related to columns, or in general, all the topics covered together. Okay. Okay. If there is no doubts, then let us proceed to the question from previous sessions that were left or that needs to be solved. Okay. So read this question first. So the question is telling, for the beam cross section shown in figure 4. So this is figure 4, which is an I section. Locate the neutral axis. So you have to find out the neutral axis for this I section. So at what depth this neutral axis will pass through, you have to determine. So how to determine? So we know y bar will be equal to a1 y1 plus a2 y2 plus a3 y3 and so on, an yn, by a1 plus a2 plus a3 plus so on. So if you want to write in summation format, it will be I equal to 1 to n ai yi by summation of I equal to 1 an. So now let us take this as bottom flange as 1, wave as 2, and the top flange as third portion. Correct? So And let us write the area for 1, 2, and 3 respectively, along with their distance of y1, y2, and y3 from a reference axis. So basically, to simplify it, let us take the reference axis as the base of this bottom plane. So let us take that to be 0, 0. Now, let us write everything then and fill this equation. Y bar will be A1, Y1 plus A2, Y2 plus A3, Y3 plus A3, Y3 upon A1 plus A2 plus A3. Correct? So we have to calculate A1, Y1, A2, Y2, A3, Y3, and A1, A2, A3 respectively. So I am erasing this equation because this equation is not needed. So let us directly feed in all those values there. So what will be the area of this bottom flange? It will be how much? 30 into 125, and with respect to the reference axis, that is the bottom of the bottom plane, where will be the centroid located for that bottom plane? It will be located at 30 by 2. So you can write 30 by 2 plus what will be A2? It will be 25 into 250. Correct? Then what will be Y2? It will be 30 plus how much? 250 by 2. Just tell me, is this okay? Is this clear to everyone? It will be 250 into 25 into, just tell me what will be Y2, that is centroid of the wave with respect to reference axis. It will be 30 plus 250 by 2. Then what will be the area of A3? It will be how much? 30 into 200 30 into 200 into how much? It will be 30 plus 250 plus 15 by, write the area, 30 into 125 plus 25 into 250 plus 200 into 30. Just calculate it and write the value in the chat box. How much you people are getting? Just let me know. Some people are saying 175, but it is 174.6875 mm. And that is with respect to the bottom reference axis. So from bottom flange, base of the bottom flange, the neutral axis will be located at 174.68 mm above. Correct? So this is how you have to calculate the neutral axis for any given section. Please note it down and let me know if there is any doubt related to this question. Is there any doubt related to this question? Okay, if there is no doubt and if you people have noted it down or written down, then shall I proceed further? Okay. So now they are asking determine the moment of inertia for the beam cross section as shown above its neutral axis. About its neutral axis. It is about its neutral axis. Okay. So how to do this? Tell me how to do this. First, calculate the moment of inertia for each and every part with respect to their centroidal axis. Okay. Then, to calculate the overall moment of inertia about the actual neutral axis, you have to use the parallel axis theorem. So let us see how to calculate this then. Okay. So I will be, you have to write the Ixx for first portion. So BD cube by 12. So 125 into 30 cube by 12. Because it is a rectangular section. Plus A into Y minus Y1 bar whole square. So A is 30 into 125 into 125 and difference of the distance between actual neutral axis and centroidal axis of that part whole square. So it will be how much? It is 30 plus 125, then minus 15. Correct? It will be 30 plus 125. That will be 155. Sorry. It won't be 30 plus 125. It will be 174.6875 minus how much? Minus 15. That will be the only difference because from reference axis, neutral axis is 175 distance above And for that, where is the centroidal axis? It is 15 millimeter above. So that 174 minus 15, if you will do the difference, you will get between those axes and whole square of that. That is the main idea about the parallel axis theorem for this question. So this is for part 1. This is for part 1. Similarly, for next part, what will be the case? It will be BD cube by 12. So 25, 250 into 25 cube by 12. So it will be how much? 250 into 25 cube by 12. 250 into 25 cube plus 250 into 25 cube by 12 then plus what will be the area? It will be 250 into 25 then the distance 174.6875 minus where the centroidal axis will be located. It will be 30 plus 250 by 2. So 30 plus 250 by 2. So 155. So this is the second. Similarly, what will be the moment of inertia for the third part? That is the top one. It will be 200 into d cube by 12 plus plus what will be the area? Will be 200 into 30 then what will be the difference of the distance between the centroidal axis and neutral axis? It will be 30 plus 250 plus 15. So 30 plus 250 is 280 plus 15. 30 plus 250 plus 15 minus how much? So it is total cumulatively coming 294, 295 minus 174.6. This is for third. Correct. So cumulatively, what value of I you are getting? Just add all those three. How much you are getting? Just tell me. So we are ending up with 1859 or 185.937 into 10 power 6. So 185.9 3 3 7 into 10 power 6 mm power 4. So this is the I value you are getting. Okay. So this is the moment of inertia you will be getting for that given cross section of I type. Okay. Now just write it down and please let me know if there is any issue. If there is no issue, then we will proceed further to the next question. Okay. So this is the third question. So in this question, they are asking if the same beam cross section as shown in the above figure is subjected to a shear force. Now they have given shear force V equal to 15 kilonewton. So your V now is 15 kilonewton. So now they are asking determine the wave's shear stress at A. So where is A? A is the point that is the line accompanying or in between, sandwiched between the top flange and the wave portion. So there we have to determine the wave's shear stress. Okay. So how to do that? So to calculate the formula of shear stress tau, we know the formula is VA y bar upon IB. Okay. Is this okay? Now we have to calculate tau at this point A. So let us calculate tau at A will be V. V is nothing but 15 into 10 power 3 Newton. Area. Area will be the portion of the area will be above this point A. How much area is getting involved in taking up the shear? So this hashed area will be nothing but 200 into 30. Correct? And the movement of that area about neutral axis. So how much it will be? It will be total height is how much? 30 plus 250 plus 30. 30 plus 250 is 280 plus 30 is 300. From there, you reduce the top half, that will be 15. So 295 minus 174.687. Okay. So to be more precise, it will be 30 plus 250 plus 15 minus 174.6. Okay. Divided by I. I is 185.9337. 'And what will be the B? B will be the width of the wave, that is 25 mm. So now calculate this. 15 into 10 power 3 into 30 into 200 into how much? Will be 2.3 Newton per mm. Okay. You understood how to calculate and why I have taken B equal to 25, because they are asking to determine the wave shear stress at A. If they would be asking the wave flange shear stress at A, then you just substitute the width of the flange, that will be 200 mm and not 25. Okay. So AY bar combinedly is movement of area of the shaded or hashed portion with respect to the neutral. Correct? Is this part clear to everyone? So now please tell me where the shear stresses will be zero. Think and tell me where the shear stresses will be zero. So now you check the formula. V can't be zero, I can't be zero, and B can't be zero by any means for any case. So A and Y bar combinedly you can make zero. So basically where the shaded area will be zero, there only your shear stresses will be zero. So shear stresses will be the area where the shear stresses or the surfaces which the surfaces which are devoid of those shear stresses will be the bottom one or the base of the bottom flange and top of the top flange respectively. So if someone asks you where shear stresses will be zero, it will be zero or the surfaces will be devoid of such stresses at the base of the bottom and the top of the top. Correct? So top flange top will be devoid of shear stresses as well as the base of the bottom plane. Okay. Please note down and let me know if there is any issue related to this question. Okay. If this is clear, then I hope the stresses in beam part is clear to everyone. both you can now calculate bending as well as shear stresses for a beam process. So before calculating that, I am assuming now that you have gained sufficient knowledge how to draw shear force and bending moment diagram. And you can calculate the shear force and bending moment coming at a given section. Then you can calculate the neutral axis, moment of inertia, all those are sectional properties. After calculating the neutral axis, moment of inertia, you can calculate the shear stresses and bending stresses or normal stresses that are coming in that cross section of the flexural member or beam member to be used. Is this clear to everyone? If this is clear, then we will proceed further to all those question, mixed question type here. So please wait for 2-3 minutes. Now let us solve some miscellaneous question. Okay. Is this okay to everyone? Okay. So let me add some slides. So are you people ready to solve some? Hello. Can anyone please tell me if I am audible or not? And sorry, there was a network issue from my side. That is the reason I got disconnected. So now we will continue that session 12 from here onwards. Okay. Please, before moving on, please let me know if everything is audible and visible or not, so that I can proceed further. Please type it in the chat box. So the questions that we have left in the previous session, now we have completed. So here onwards, the question will be miscellaneous type and it will be mixed and matched from different chapters what we have read till this point. Okay, so let me take some questions. Let us take some questions that has already came and some good questions so that you will be able to understand how the questions might come and how to tackle those type of questions. Okay. So please give me 1 2 minutes so that I can identify some good questions and give it to you. Huh. So write the question now. This is the question of engineering service exam. So a simply supported beam is loaded as shown Okay. So now let me draw the figure. Let me give you the figure. Then you try to solve this by yourself. As we have read each and every concept, this is a straight beam. This one side is hinged one and one side is roller. A load 4 kilonewton is there and 4 kilonewton, 4 kilonewton. 4 kilonewton meter and 4 kilonewton meter are acting. This is A, this is C, this is. So they are asking determine the bending moment at C. Let me draw the figure more clearly, otherwise it won't get clarified. Start writing the question and start analyzing it, what they are asking. Okay, this is point A, this is point B, and this is C. Total length is from here to here it is 2. So this is 4 kilonewton meter and this is 4 kilonewton meter. This is 4 kilonewton. This length is 2 meter and this length is also 2 meter. Okay. Now you have to determine the bending moment at C. So how to do this? First, step 1. Calculate reaction at supports. How to do this? Just write the equations of equilibrium and you will get the, what you will get. Just write the equations of equilibrium and you will get the support reactions. First do that. What can be written? If you write summation of f x0, so you will get this HA to be 0. Summation of Fy equal to 0, if you will write, what you will get? RA plus RB equal to 4 kilometer. That let be equation 1. And then summation of movement about point A, if I write, and I am taking and clockwise to be positive. So 4 minus 4, 4 minus 4, okay, 4 plus 4 into 2 minus 4, then minus RB into 4 will be equal to 0. So 4 plus 4 into 2, 8. 8 minus 4 is 4 and 4 by 4. So RB you will be getting 4 upon 4, so 1 kilometer. Okay. Have we done it correctly? Just check. Clockwise, we are taking positive. So 4 minus RB into 4 plus 4 into 2, then minus 2. Oh, okay, okay. This is 4 plus 8 is 12. 12 minus 4 is 8. 8 by 4 is 2. So it will be 2 kilonewton. That is the reason I was thinking why it is coming out to be 1 kilonewton. So if RB is 2 kilonewton, so upon substituting RA, you will also get 2 kilonewton. So now we got every reaction. So let us take this section 1 and write the equation for MXX. So MXX will be how much? MXX will be how much? This is X. This will be BXX. This will be MXX. Okay. So MXX will be 2 into X minus 4. Okay. So MXX at X equal to 2 meter, MXX will be how much? 2 into 2 minus 4. So it will be 0 kilonewton meter. So your answer will be bending moment at C will be 0 kilonewton meter. That means at mid span, the bending moment will be 0. Okay, getting it? Please write it down. Please write down the solution and let me know if there is any issue you are facing. Okay. Can you people draw the bending moment diagram for this question? Now check if the beam and the loading is symmetrical, your bending moment will also come to be symmetrical. So if you want to draw the bending moment diagram, the bending moment diagram will come somewhat like this. So this is your beam. This is the load. This is the movement. So your bending moment diagram will come something like this. -4 to 0 and so negative. Okay. And what about shear force diagram? Shear force diagram will come somewhat like this. Okay. Is this clear to everyone? Please let me know if this is clear. Okay, take your own time and write it down. Then we will move to a next question. Is this question done? Okay, not yet. Okay, write it down quickly. So this is your BMD and this is your SFD. Is this done? Okay. Let us solve one more question. Determine the reaction at C. Hmm. You have to determine this value RC. So how to do this? Now tell me at internal hinge, what will be zero? We have read that the bending moment will be zero at point P because of the internal hinge. So if you write summation of moment about point B equal to 0 from right hand side, you will get RC into, and this is 1 meter. Everything is 1 meter, 1 meter, and 1 meter. Okay. So RC into 1 minus 30 into 2 will be equal to 0. From here, you will get RC equal to 30 into 2 upon 1. So equal to 60 kilonewton. So your answer is 60 kilonewton. Everyone is getting this, how we have written this part or not? Okay. So write next question. So now let us solve one question of a hanger bar. Okay, so beam is like this. Here it is hinged, and here it is roller, and here we are having a 60 kilonewton load, and here a L-shaped bar is there from which two reactions are coming out. One is 60 kilonewton and another is 30 kilonewton. Okay. Sorry, 120 kilonewton and 60 kilonewton respectively. So this point is point A, B, C, and D. And this is point. Now they are asking what will be the reactions at supports. So how to calculate? First, take this L-shaped bar out and draw its free body diagram. Okay. Now, two reactions are there. This is 120 kilonewton, then this is 60 kilonewton. So, 120 kilonewton is acting upward. So, here you have to show 120 kilonewton is acting down. So 60 kilonewton is acting rightward. So 160 kilonewton reaction will come which will act in the opposite direction. Now, with respect to forces, everything is balanced. But now check this 120 kilonewton up and down will try to rotate this bent up bar in which fashion? It will be in anti-clockwise fashion. And the 60 kilonewton will try to form a couple and which will try to rotate this bar in clockwise fashion. So this can be divided into two bars respectively. And using method of superposition, you can just add this up to get the final output. Okay. Now this 60 and this 60, this 120 and this one. So now this 60 will try to rotate this L-shaped bar in clockwise direction. So if we put a resistance or movement in anti-clockwise fashion, so and that will be how much? Let this be 2 meter and this be 2 meter. Let all those are 1 meter, 1 meter and 2 meter. Okay. Now these 60 and 60 are separated by a distance of 2 meter. So 60 into 2, 120 kilonewton meter will be the movement that will get generated. Now this 120 and 120 are separated by 2 meters. So they will try to also rotate this L-shaped bar in which direction? It will be in, yes, anti-clockwise fashion. So to restrict that movement, what we should apply? A resistance in anti-clockwise manner. Or sorry, a resistance in clockwise manner should be applied just in the reverse direction so that equilibrium is maintained. So now it will be 120 into 2 kilonewton meter. So 240 kilonewton meter. So overally, what is the movement you are getting? It is 240 kilonewton and 120 kilonewton respectively in anti-clockwise and clockwise direction. So if you superimpose now, what movements you are going to get at joint B? It will be 120 minus 240. So minus 120 kilonewton in anti-clockwise direction or 120 kilonewton meter in clockwise direction. So let us show here it is 120 kilonewton. Till this point everything is clear. Now if anyone is having any doubt, please let me know. No doubts? Okay. Now this is the free body diagram of this L-shaped pentagon. Now, at that point B, equal and opposite reaction needs to be balanced. So when you will show those reactions in the beam directly, so you have to show in just the reverse order what you have got in that Ventuck L-shaped bar. So now 120 is acting downward. So here 120 will act upward. 60 is acting to the left. So 60 kilonewton here will act to the right. And 120 kilonewton meter is acting in which way? It is clockwise direction. So in the beam, you have to show it in anti-clockwise manner. So it will be 120 kilonewton meter. Now this is joint A and 1 meter distance are there, and here it is 3 meter and this is 60 kilonewton. This is joint A, B and C. Now this became a simply supported beam with AD part being the overhang portion. Now you have to calculate these reactions RA, RB, RC and horizontal reaction RAH. So now if you do summation of Fy equal to 0, what you will get? You will get RA plus RC plus 120 minus 60 equal to 0. And I am taking upward to be positive. So RA plus RC will be equal to 60 minus of 120 or plus 60 will be equal to 0. So that implies RA plus RC will be equal to minus of 60 kilonewton. So RA plus RC equal to minus 60 kilonewton. Let this be equation. Now RAH will be equal to 60 kilonewton directly. You can see by or write by summation of Fx equal to 0. Now, if we do summation of movement about point C equal to 0, what you will get? Just tell me. You people want to take the movement about A? Okay. Let us do summation of movement about point A equal to 0. Now write the equation then. It will be RC into what will be the lever arm? 2 meter plus 120. What will be the lever arm? 1 meter plus 60. What will be the lever arm? It will be 0. So 60 into 0 is 0. So I am neglecting that part. Then plus 120 and plus 60 into how much? 3. So RC will try to rotate the beam in anti-clockwise manner about A. 60 won't do that because it is passing through A. 120 will try to rotate the beam about A in anti-clockwise manner. 120 kilonewton meter anti-clockwise movement is also present at point B. And 60 kilonewton at the far end of the overhang will also try to rotate the beam in which direction? It will be in anti-clockwise. So 60 into 3 is the lever arm. So that will be equal to 0. So now solve this and tell me the value of RC. So RC, someone is telling it's coming out to be 210 kilonewton. So if RC is 210 kilonewton and that is minus sign, that means our assumed direction of RC is just the opposite and it should go downward, not upward. So now substitute RC to be minus 210 in this equation 1, you will get RA. So what is the value of RA? Please let me know. RA will be 210 minus 60 is 150 kilonewton. So you are getting RA to be 150 kilonewton, RC to be minus 210 kilonewton upward or 210 kilonewton downward respectively. And horizontal reaction at ARAH you are getting to be 60 kilonewton. So is this type of question that is a bar which is L-shaped? If such problems are existing, now can you solve the support reaction for such type of questions? So basically, is this question clear to everyone? If no, please let me know. These are some of the typical type of questions that you may encounter in your final exam also. So please be careful in understanding. Please note it down. I am giving time, note it down. And if there is any issue, please write the issue in the chat box or directly talk to me. Okay. So there is a doubt how these movements I am writing. So now please tell me this 60 kilonewton and this 60 kilonewton are separated by some length, that is 2 meter. If they are separated by 2 meters, so these 60 and 60 will try to rotate that bar in which fashion? It will be in clockwise fashion. So the entire bar is not in equilibrium right now. So to bring that bar into equilibrium, you have to apply some movement, and that movement needs to be applied at joint B. And how to apply that movement? It should be opposite to how those 60 kilonewton forces will try to rotate that bar. And if they are rotating the bar in clockwise fashion, so how you have to apply those movement reaction? It will be in anti-clockwise fashion to keep the entire portion in equilibrium. So that is the reason I have shown the movement in anti-clockwise fashion. Similarly, analyze for the second portion, that is 120 kilonewton upward and downward force has been separated by a distance of 2 meters. If they are separated by a distance of something, then they will try to rotate that bar in anti-clockwise fashion. If they want to try to rotate this bar in anti-clockwise fashion, then this bar is not in equilibrium. To bring that to equilibrium, you have to add some resistance. That resistance will come in the form of this movement that I have shown here. And the value of that movement will be the force into their lever arm. And what will be the lever arm? It will be 2 meter. So 120 into 2 will be 240 kilonewton. And that 240 kilonewton meter will be the resistance in form of movement that will be acting at this point B, such that the whole component or the whole structure comes to equilibrium. Correct? So after that, you just superimpose those two images to bring that to your original beam structure, and just write all those reactions and movements that will form or that will complete the given structure. And then try to analyze the structure using the equations of static equilibrium respectively. And that is what we have done throughout this question. Is this clear to everyone? Please write this down quickly so that we can move to our next question. Okay, then let us proceed to our next question then. So our next question is a question that came in engineering service exam. Okay. Okay. So let us write our next question then. A simply supported T beam section or of T beam of a simply supported beam of T section is subjected to a UDL to UDL acting vertically downward. Its neutral axis is located at 25 mm from the top of the flange. From top of the flange. From the top of the flange. And the total depth of the section is 100 mm. Total depth of section is 100 mm. The ratio of maximum tensile stress to maximum compressive stress in the beam will be the ratio of maximum tensile stress to maximum compressive stress. Each or will be how much? So that means you have to calculate sigma max tensile and sigma max compressive. And the ratio will be your desired answer. Okay. So how to calculate? Just read the question once more and identify the chunks that they have provided to solve the question. Everything has been provided in the question itself. Just you have to find out which are the main part that needs to be taken care of. Please tell me how to calculate this. Now they are telling the beam is of T shape. Okay. So if the beam is of T shape, so there should be some neutral axis and the beam is loaded with UD. So these are additional things. So let the beam be loaded with UDL like this. And the total height or the total depth is 100 mm. Okay. And the neutral axis is located at a depth of 25 mm from the top length. So they have given one more chunk, that is 25 mm is the location of the neutral axis from the top side. Now if UDL is acting downward, so compressive stress will try to generate on the fibers above the neutral axis, and similarly tensile stresses will be produced on the fibers below the neutral axis. Correct? Now, if that is the case and we know our stress diagram will be linearly varying from positive side to negative side, means positive is tensile and negative is compressive or vice versa. And if sigma compressive maximum will be given by M by Y into YC, and sigma tensile will be given as M by Y into YT. This YT and YC are respectively measured from neutral axis. So if you take sigma max tensile, it will be M by I into YT. Similarly, M by Y into YC will be the sigma max compressive. So sigma max tensile upon sigma max compressive will be nothing but YT upon YC, because M by I ratio will get deducted both from the top side and bottom side because they are constant. So YT by YC will provide you the answer for your desired question. So YT will be 100 minus 25 and YC is 25 given. So 100 minus 25 is 75 and divided by 25 will give you the desired result of 3. So your answer should be 3. Now, please tell me if all these steps that I have done is okay for you or not. If there is any issue, please let me know right now. So, is the question clear to everyone? And more importantly, if the steps are clear or not. If this is clear, let us proceed to our next question. Okay. Then let us move to our next question. Okay. So let us write our next question. Hmm. A mild steel, sorry, wait. A mild steel structural section each in unsymmetrical I section with the greater width at the top Sorry. Greater width at the bottom and smaller one. Wait. Greater width at the top and smaller one at the bottom. The overall depth of the beam is 250 mm, 200 mm, and the flange stresses are 120 Newton per mm square and 60 Newton per mm square, 120 and 60 Newton per mm square, respectively. What is the height of the neutral axis from the bottom? So read the question carefully. Note down all the details they have given and try to solve the question. And if not, I will solve it for you at the end. Please keep patience and try to solve it by yourself. So let me read the question one more time for you people. First of all, you people please write this question, then I will read and try to understand what difficulties you are facing. First, write this question. Okay. So let me read the question for you people. A mild steel structural section is an unsymmetrical I section with the greater width at the top and the smaller one at the bottom. That means your I section will be looking like this, something like this. Okay. And the overall depth of the beam is 200 mm. That means this is 200 mm. And the flange stress is 150 Newton per mm square at top and 60 Newton per mm square at bottom. That means this is 150 and this is 60. This much information has been given to us. So this is 150. This is 60. And neutral axis will be somewhere here where your stress will be 0. So let this top part or let this bottom part, top part be x and bottom part be 200 minus x. Now, from similarity of triangle, can you write 200 minus x upon 150 will be equal to x upon 60? So 200 minus x into 60 equal to 150x. So 200 into 60. So 6 2 are 12. 12 into 1000. So 12,000 minus 60x equal to 150. So 12,000 minus 60x equal to 150x. So 210x equal to 12,000. So x will be how much? Just simplify and give me the value of x. So x will be 12,000 by 200. Or since they have asked the value from top, so let us further simplify this without taking 200 minus x at top, rather than taking x directly for the top times and 200 minus x for bottom. So now 200 minus x upon 60 will be equal to 1 x upon 150. So 60x will be equal to 200 into 150 minus 150x. So 210x will be equal to 30,000. So x will be equal to 30,000 upon 200. So 142.8. mm. So your neutral axis will be located at a depth of 143 roughly from the top fiber or the bigger flange. Okay. So is this question clear? Okay. So let us move to our next question. Okay. Now write the span length is 2 meter. The cross section of the beam is hollow square with external sides of 100 mm. I is given 4 into 10 power 3 power 4. The shape bending stress for the beam material is 100 Newton per mm. So the load at three end will be how much? So that means they are telling a cantilever beam is there whose length is 2 meters. The cross section of the beam is a hollow square with external sides of 100 mm and its moment of inertia they have given. The shape bending stress they are telling, shape bending stress means sigma shape they are telling is 100 Newton per mm. Okay. And moment of inertia, they have given 4 into 10 power 5 mm per. Now we know m by I equal to sigma by 1. Correct? Now you check I is given and movement you have to calculate due to this point load at the far end which is P. So if load is P and L is 2 meter, so 2 into P will be the maximum moment that will be carried by this cantilever beam. So 2 into P by I, which is 4 into 10 power 5, equal to sigma by Y. So, and Y will be how much? Y will be 50 mm because it is square. So 2P into 50 by 4 into 10 power 5 equal to 100. So from here, P will be 10 square into 4 into 10 power 5 by 2 into 100 by 2. So 2 will get cancelled out. So it will be 4 into 10 power 7 upon 100. So 4 into 10 power 5. 4 into 10 power 5 Newton. So it will be 4 into 10 square kilonewton or 0.4 meganewton. So it will be 400 kilonewton. 400 kilonewton is the load that can be applied at the free end such that the shape bending stress will be 100 Newton per mm square. Is this question clear? M will be P into 2. I will be I. Sigma is given and Y will be given. So P 2P by 4 into 10 power 5 equal to 100 Newton per mm square, and along with that Y will be 50 mm. So from here, if you substitute P, you will get 100 into 4 into 10 power 5 by 2 into 50. So 100. So it will be 4 into 10 power 5 Newton or 400 kilo will be your answer. And one more thing, we have done a mistake here is that we have directly taken P to be 2, but it won't be the case because everything is in mm, so 2000 mm. So you have to write here 2000 mm. So upon substitution, you will get so P into length, that is 2000 mm, and I is I. P into 2 upon I equal to sigma is sigma and Y is 1. So 2 meters. So 2000 millimeter into P by I is 4 into 10 power 5. Sigma is 100 Newton per mm square and Y is 50 mm. So from here, if you substitute, P will be 100 into 4 into 10 power 5 by 2000 into 50. So from here, what you will get, just simplify this and tell me the answer. You are getting 400 Newton. So 400 Newton is the safe load that can be applied as a point load at the farm. So this is your solution for this question. So with this, we are coming to the end of this session. So thank you everyone for joining this session. Now the stage is all yours. Please let me know if there is any query related to this session. If no, then we will wind up the session. So thank you everyone for joining and good night.